In this video, we're going to be talking about quadratic equation applications. So this one says a right triangle has a hypotenuse that is 13 centimeters long. If one leg is 7 centimeters longer than the other, find the length of each leg. So if we start out by drawing our triangle, we know that the hypotenuse is 13 centimeters, and then one leg is 7 centimeters longer than the other. So if one of them is x, then another would be x plus 7. And so what we need to do now is use the Pythagorean theorem that says a squared plus b squared equals c squared, where a and b are legs and c is the hypotenuse. So we would say x squared, take x as one of our legs, plus x plus 7 squared is equal to 13 squared. And now we need to simplify and solve this quadratic equation. So we would write out the x plus 7 times x plus 7. So we end up with x squared plus 7x plus another 7x to give us a 14x plus 49. We still have this x squared, and it'll equal 13 squared, which is 169. And then we want to combine like terms. So we would add our x squares together to get 2x squared. And then we have plus 14x. And then right here, let's subtract the 169 over. And the reason we do that is because we want that side to equal 0. So we would take 49 minus 169. We'd get negative 120. And now we would want to solve from here. Before we try to factor it or use the quadratic formula, we can see that all of them have a 2 in common, so we can divide everything by 2. And when we do that, we end up with x squared plus 7x minus 60 equals 0. And now we want to solve by factoring if we can. So we want two numbers that multiply to be a negative 60 that add to be a positive 7. So if we start listing all of them out, like 20, negative 20 and 3, 12 and 5, looks like that will work. So we have plus 12 and then minus 5. And then we've got x plus 12 equals 0, x minus 5 equals 0. So if we solve for x here, we get a negative 12. For here, we get a 5. Well, we can't have a negative 12 on this application problem because we're talking about length, and length cannot be negative, but we can have x equals 5. So it wants the length of each leg. So if we take that back here, we know that, okay, well, one of them is 5, and the other one is x plus 7, and we know that x is equal to 5, so we end up with 12. So one of the legs is 5, and one is 12. And one way you could check this is by now using the Pythagorean theorem again to say 5 squared plus 12 squared and make sure that equals 13 squared, which it does. So that means your two answers are correct.